Hello everyone, welcome to my channel The Colors of Mathematics, and today we are going to discuss the Euclid's division lemma. Now this lemma or statement, lemma means statement, is related to division. So before understanding the Euclid's division lemma given by Euclid, let's understand about division. So what is division? Suppose I have 9 toffees with me and I want to distribute these 9 toffees equally among 3 children. So my division statement will be 9 divided by 3. And what does this mean? This means that I am going to make groups of 3. So this is the first group. Now this is the second group. And this is the third group. So when I have 9 toffees and I have to distribute among 3 children, so each one of them will get 3. So do you agree that I can write this in a single statement like this? 9 toffees are equal to 3 times 3. Okay, now let's look at a different scenario. In this scenario, we have 10 toffees in place of 9 toffees. So the division statement first becomes 10 divided by 3. And now let's look at the groups. We have the first group of 3. We have the second group of 3. And we have the third group of 3. Did you notice that the one toffee is left, which cannot be distributed? So this time, can I write a statement of this kind? 10 is equal to 3 times 3 plus 1, because 1 toffee cannot be distributed, and 3 multiplied by 3, we have 3 groups of 3 plus 1, which is equal to 10. Now let's imagine if there are 11 toffees. The division statement would look like this, and we can write another statement that 11 is equal to 3 times 3 plus 2. Again, we can also have 12 divided by 3, and the division statement will look like this. 12 is equal to 3 times 3 plus. Now, when we are going to have 12, and we know 12 can be divided into 4 groups of 3. So we will write 3 times 4, and no toffee will be left outside. So let's look at more statements where the divisor is 3 only. Let's take the number 13 now and divide by 3. We get 13 equals 3 times 4 plus 1. We can have 14 divided by 3, and we get 14 equal to 3 times 4 plus 2. Then we can have 15 divided by 3, and the statement would be 15. Now we can have 5 groups of 3. So simply there would be no remainder. And see, the statement looks like this. So now let's look at the statements and try to observe. Here everywhere, this number is the dividend, this number is the divisor, and this number is the quotient. Dividend, divisor, quotient, and remainder, whatever is left out. So everywhere it is like this. Let's look at the remainders. The remainder is 1, 2, then nothing. That means 0. Then 1, 2, then nothing. That is 0. So you can check, does it happen the same way with 3? You pick up any number and divide it by 3 and try to make this division statement for 3. Do you get a remainder greater than 3? So you can check this. This is the assignment for you. I will tell you what you will observe. You will never get a remainder greater than 3. You will greater than 2. You will always get 0, 1 or 2 as the remainder. See, either the number will be a multiple of 3. That means we can say the number can be of the form 3q, where q is the quotient and 3 is the divisor. The number can give a remainder of 1 when divided by 3. So that means the number can be of the form 3q plus 1. That means where the 3 is the divisor, q is the quotient and 1 is the remainder. And the third case can be that the number can be 3q plus 2, where 3 is the divisor, q is the quotient and 2 is the remainder. So if divisor is the number 3, we have only 3 possibilities, that there are only 3 categories in which the number would come. Now let's take any number. You also can do this exercise. You can think of any number in your mind and divide it by 3. Say I take the number 144. And we need not divide it also because we know the divisibility rule of 3. We just need to add the digits 1 plus 4 plus 4 and that gives us 9. So 9 is a multiple of 3. That means 144 is also a multiple of 3. But still, if you want to find out the other number, like you can divide by 3, let's see what do you get as the quotient. So you get 48. So that means 144 can be written as 3 times 48. So this is of the first category. It is of the form 3q. Now let's take any other number. So the number coming in my mind is 76. Now let's divide it by 3. So you get 2 times 3 is 6. So you get 1 remainder. You get 25 and 1 would be left. That means 1 is the remainder. So that means you can write the number 76 in the form 3 times 25 plus 1. It falls into the second category, that is 3q plus 1. Now let's take another number. Let's take 86 and divide it by 3. Again 3 times 2 is 6. So 2 will be left, 8 and plus 2 will be the remainder. So this in the number 86 falls into the third category, where 3 times 28, 3 is the divisor, 28 is the quotient and 2 is the remainder. So this falls into the third category. Similarly, you can play with numbers. You can pick up any number, divide by 3 and see does it fall into these 3 categories, and it will definitely fall into these 3 categories. So you can do this same exercise with another divisor. Let's take another divisor. Let's take the number 6. Let's think of a number. Let's think of a number 36, which is a multiple of 6. Now 36 can be written as 6 times 6, where 6 is the divisor and 6 is the quotient and 36 is the dividend. Next number is 37. So 37 can be written as 6 times 6, that is 36 plus 1, and this 1 is the remainder. The number 38 can be written as 6 times 6 plus 2. The number 39, 6 times 6 plus 3. So similarly, you can go on writing the numbers and you will, when you observe, you are going to find something. So here I have written down a list of numbers with the dividend equal to, then we have the divisor, the quotient, and the remainder if any. So now look at the remainders. The remainders, when the divisor is 6, we get only 0, 1, 2, 3 or 4 or 5 as the remainders. We never get 6 or a number greater than 6 as the remainder. So this tells us that the numbers that when we divide by 6, we get numbers which are of the form, let's write down the numbers, the categories of number when the divisor is 6. When the divisor is 6, either it can be a multiple of 6. That means no remainder. So it is of the form 6q. That means where 6 is the divisor and q is the quotient. Then 6q plus 1. Then we have 6q plus 2. 6q plus 3. 6q plus 4. 6q plus 5. These are the only 6 possibilities which we are going to get with the number 6. So you pick up any number. Again, we can do the same exercise as we did with the number 3. You pick up any number, say the number 32. So 32, we all know 5 times 6 is 30. 6 is the divisor and 5 is the quotient, plus 2, where 2 is the remainder. So it is of the third form, 6q plus 2. So any number you pick up and you divide by 6, you are going to get a number, one of these, which will fall into one of these forms. So now let's sum it up. You can play with all other numbers. You can take any other number as a divisor and play like with numbers like this, and you can discover their forms. So but in order to, let's sum it up. If A is the dividend and B is the divisor, so we can either get a number which is a multiple of B, or we can get a remainder. Now the remainder should either be 0 or should be less than B. We have seen it. It is less than, here it's either 0 or it lies between 0 and 5. It cannot be 6. Same way we saw with 3 also. We never got the remainder equal to the divisor. So we get a statement, a generalized statement. A is equal to BQ plus R, where R lies between 0 and B. So this is known as the Euclid's division lemma. Now, when you have written down the statement, Euclid's division lemma, you have understood the statement, you can discover the forms of different numbers. Like you can have different divisors and you can get the forms. So for example, if you have the divisor 5, so the forms of number when B is 5, say B is now 5, so R can be either 0, 1, 2, 3 or 4. So the dividend can be either 5q or 5q plus 1 or 5q plus 2 or 5q plus 3 or 5q plus 4. So when the divisor is 5, we can have the numbers of these 5 categories only. So you can play with numbers, pick up any number, test these forms, and the number will fall into any one of these categories. So I hope the Euclid's division lemma is clear to you, and in my next video I am going to explain the problems related to Euclid's division lemma. Thank you. Goodbye.